So what do we always make our first? Yeah. So you could do this, int x, y, z. Then you could say cout, enter 3 nums, yo. And then we could read into all 3 of them at once. And the reason that works is if you type a whole bunch of stuff and then hit enter, all of that stuff is stored in the input buffer. And then what CIN does is it tokenizes your input, meaning that it ignores the white space, and it uses the white space, the spaces of the tabs or the enter key, in order to differentiate the pieces of data that you're giving it. So I type in 1, 3, and 5, and that's enough. I mean, not that that's enough, but it actually stored 1 into x, 3 into y, and 5 into z. If I only enter 2, 1 and 3, I forget to enter 5, it just sits here waiting for me to type the third thing. It's ignoring all this white space, still wanting me to fill in something that would fill in z. Now I'm going to type 5. And now it's finally done. That's kind of important to remember, because if you ask for a certain number of bits of information and then the user enters too many pieces, then that whatever they entered is left there in the buffer and can cause a problem later, like this. Downside include string. We have a string. Now we're going to read into the string after displaying. Enter your name. Then we're going to print out the name, just because your name is name, followed by an ENDL. Did that wrong. Okay. So I run it. And let's say that I can't read, and so I type in 4 numbers. 1, 2, 3, 4. Then it says, enter your name. Well, guess what it did? Why is it saying your name is 4? It's because that 4 was already sitting there in the input buffer, and so by the time CIN came in again, it read that into the name field. You can clear your input buffer, though. You can do CIN dot I've forgotten what it is.
Clear?
Is it?
It's a guess.
I can't believe I've forgotten it. Clear is there. What that does is it clears out the input buffer so that there's nothing waiting, so that the next time you call CIN, it won't be filled in with whatever they had already typed in. So they could fill it full of garbage data, but with that clear there, oh, okay, we're going to forget that for now. We'll hit that point later. Just letting you know, if you type in too many things, then it'll get stored into additional CIN calls. order is important. The first value goes into the first variable and so on. So if we do this, CIN into height and width, and they're supposed to enter two values, then the first thing they type goes into height. The second thing they type goes into width. Forgive me for ignoring the pages full of stuff. I will zoom in if I think it's important, but usually what I'll do is I'll type it in myself with an example. I know that my eyes always rolled up and I started, drawing on my notebook whenever the teacher had a page full of code on the screen, but I'm hoping that typing it makes it more interesting.
Clear resets the stream state. Send.ignore and then supplying it int max will make it read to the end of file. You can tell it how much to ignore, which I think is int underscore max.
Okay. I'm going to leave it like that first, but then, yeah. Okay. I wasn't expecting that behavior. We'll keep working on that. I don't know why I've had a brain fart on that. Mathematical expressions. A mathematical expression is a series of values which are either literals or variables or both. And if there's more than one, they will be separated with operators. Operators like plus, multiplication, minus. Have we covered Pemdas yet? You've covered it, but that's because you've taken another one of my classes. Pemdas means parentheses, exponent, multiplication, division, addition, and subtraction. So if you do this, A is equal to 3 plus 5 times 2 minus 1 times 3.
I always remember, please excuse my dear Aunt Sally.
Pardon me?
But please excuse my dear Aunt Sally.
Yeah, please excuse my...
I don't know what you're talking about.
I guess if you have an ant farm, you might have an ant named Sally. Okay, ignore that. Okay, so Pemdas. P meaning parentheses. E meaning exponents. I do not believe that there's an exponent symbol in this language. In some languages it's that, in some languages it's that. This language doesn't have an exponent, so we would just put C++ doesn't have exponents. Exponents. And then multiplication, division, and modulus all occupy the same precedence. And if things are at the same precedence, you just do them left to right. So multiplication, modulus, and division. And then lastly, addition and subtraction. Why is that important? Because it tells us the order in which this would be solved. If we just sat there and grabbed a calculator and we typed 3 plus 5, the calculator would display 8. Times 2, it would display 16. Minus 1, it would display 15. Times 3. So the calculator would tell us that this is 45. But it's not as far as the computer is concerned. This is a single expression. So it will be parsed, it will be processed according to the precedence of the operators. Meaning that parentheses get done first, and then within those expressions, multiplication, division, and modulus happen before addition and subtraction. Are there any parentheses in this one? No, so we're good. We don't have to do any P's first. Then what's the next thing we're going to do? Well, I see 2 multiplications. So we'll just do those left to right. When you have things that are at the same priority level, you do them left to right. So, what's the first one? A is equal to 3 plus, what's 5 times 2? I think it's 10. Yeah, and then what's this next one? 1 times 3? 3. And now we don't have any multiplication or parentheses or anything else like that, so we just do it left to right. 3 plus 10 is 13, minus 3 is back to 10. So that's how those are solved. And you did this probably in algebra or in grade school math or something like that, so you're probably already familiar with it. What is A equal to and what is B equal to? 17 on the first one because 3 times 4 is 12. We do multiplication first, and so what is B? 23 because we did this multiplication first. If there are any parentheses thrown into the mix, you have to do those first. So C is equal to 3 plus 4 times 5. I'm going to lower that to 2. I don't like multiplying numbers so large. Okay, so what does that equal to? Yeah, that's equal to 14. And you see why, right? Because this had to be done first. If this expression was complicated, you still have to follow the rules of precedence inside the parentheses. Something else to mention at the same time, besides precedence, is composition. And composition is how algebraic expressions are coded into the computer. So if I say that area is equal to 2 pi, circumference is equal to 2 pi r, something like that. You would not type that into the computer that way. Java would not, C++, in this case, in that case, both syntaxes are identical, would have no clue as to what was going on there. The way you have to do it is you have to go in and fill the missing things. Now in algebra books, if you put two things by each other, it means that they're multiplied, but not in the computer. You have to actually put the star there, and then we would do that. And also in algebra books, if you have something followed by a parentheses and something else, it can just mean multiplication. But you can't do that. You actually have to put the the multiplication symbol in there again. So if you see the expression in your book, A is equal to 2 BC, and B and C are actually two separate variables, how would you word that? You would do A is equal to 2 times parentheses B times C. And then if you're savvy, you could go, well, I really don't even need those parentheses. If it was A is equal to 2B plus C, then you would say A is equal to 2 times parentheses B plus C. You just can't leave out the pluses. I mean the multiplication symbols like they do in the books. The other thing is when you have divides, division. If you say X is equal to 2 pi over X plus 3, you can't just write it like this. X is equal to 2 times pi divided by X plus 3. Why is that wrong? Because it would do all this math first and then it'd tack 3 onto the answer. That's not what we want at all. How would we fix this? Y'all are teasing me, right? We'd use parentheses to enclose the denominator. And you may as well use parentheses to enclose both parts. 2 times pi divided by X plus 3.
Just like you would do in a graphing calculator.
Exactly. Right. We're entering this stuff exactly like you would do on a graphing calculator or any calculator that was more sophisticated than just the for function and an equal sign one, where you can type in an entire expression before you hit the enter key.
Like an 84 or 89.
Yeah. So that's composition. So if I give you an expression like that, then on the quiz or the exam, I'll say turn that into C++ code. And you'll just say x is equal to 2 times pi divided by parentheses x plus 3. That would be a full credit.
But you can do the parentheses on top too, right?
It's totally cool to do that. I prefer doing that. It's not strictly necessary. The reason this part is strictly necessary is because the precedence of this is lower. So it would mess it up if we did not enclose this in parentheses. It would treat it like that, which of course is a completely different thing. I like putting parentheses to make this stuff clear. I think there's nothing wrong with putting more parentheses than are strictly necessary. Now you can go nuts. You know. Would you do that? No. So that's composition. Book says A is equal to 2B. You have to type, write A is equal to 2 times B. Book says A is equal to 2 over B plus 1. Then how would we word that? We would say A is equal to what? 2 divided by what? B plus 1 in parentheses. Like that. Okay, so we've covered precedence, we've covered composition. I love the fact that this actually gives us the answers so that we can't work it out ourselves. Stop that. Okay. There we go. All righty. What's this one? What do we do first? Multiplication, right? So,
That'd be 8.
yeah, these numbers are pretty small now. And if I zoom in, it's going to give you the answers yet again. Here we go. Anyways, so that's 8 plus 5, 13. What gets done first here? The division. So what 10 divided by 2 is 5. Minus 3 is 2. What gets done first in this expression?
12 times.
Right. So 24. 8 plus 24, whatever. Okay. This is got our good old friend modulus. That's the first thing that gets done here because modulus is at the same precedence level as multiplication and division. So what's 17 modulus 2? 1. Right, because 2 goes into 17 a certain number of times with a remainder of 1. So 4 plus 1 minus 1 is 4 again. We have the idea. They talk about the associativity of operators. And the slide is wrong. So every time I see it, I always forget that I should upload a fixed copy of it. So there's an unary operator as well as the binary operators. And the unary operator is just the minus sign. Because if you're going to do A is equal to minus 1, that's an operator. It takes that 1 and it turns it negative. And it is treated left to right. Left to right. No. Forget the associativity page. I spaced on exactly how to describe it. Oh, let's go get an explanation of it. The associativity, also known as the fixity of an operator is a property that determines how operators of the same precedence are grouped in the absence of parentheses. And so in the absence of parentheses, addition is done left to right. Multiplication is done left to right. That's really all that's important about that. But this said that the math operators are associated to right to left, and that is incorrect, because you go left to right. Frankly, I don't know how you would wind up with more than one unary negation at the same time. Because you could do like x is equal to -1, but you can't really do x is equal to minus minus 1. Is that positive 1? Let's find out. X is equal to minus minus 1. Yeah, that's what I thought. Minus minus is a decrement operator. So I don't like that associativity page, and I should just remember to delete it before next semester. But things are done left to right. If there are parentheses involved, you do the parentheses first. We know that. Algebraic expressions, just like we were talking about. y2 minus y1 over x2 minus x1. I would put the top in parentheses and the bottom in parentheses. If you're only doing multiplication on top, you wouldn't strictly have to do parentheses on top. I think it makes it clear to read anyways. But if you're doing addition or subtraction on the top, you absolutely have to put the parentheses in them. Same for the bottom. If you're doing addition or subtraction on the bottom, you absolutely have to put the parentheses in them. Or you could express it as multiple steps. Say we have y2, y1, x2, x1, and we wanted to be as wordy as possible about how to express it. That's our goal in life. Okay, so we have int y2 is equal to 3, 2, y1 is equal to 1, and then we have int x2 is equal to 2, x1 is equal to 1, and now we're going to make m. We could do this. M is equal, let's go look at the equation. M is equal to y2. Now this is going to make me feel like I'm using an old HP calculator with Polish notation. M minus equals y1. No, I can't do this all in single operators. Divided by x2 minus x1. Anyways, you see what I'm saying? You could take several steps to do this. I'll rewrite it in long form. M is equal to m minus y1, and then m is equal to m divided by. And that's totally cool too. If you think that the expression would be better served by breaking it up into several steps rather than wording it like that, go for it. The key is to make it as readable as possible. The computer isn't going to do it faster just because you put it on one line. These things have optimizing compilers in them, the C++ compilers, which make sure that your math expression is going to be solved as fast as possible for the computer, no matter if you broke it up into one statement or 3 statements like I did here. So to write 312, we know that we'd have to put a parentheses in there, 3 times 12. To write 4xy, we know we'd have to put 4 times x times y. All right, yay, new part. When we mix apples and oranges, type conversion. If the operations are formed between operands of the same type, then there's no conversion necessary. If you have a plus b and both a and b are ints, great, nothing gets converted. However, if a is an int and b is a float or a double, then one of them has to be converted to the other. Why is that? Because floats and ints are stored completely different inside the bits. You know, float has a mantissa and an exponent, and so it's got a completely different bit pattern, even if the number looks like it's the same. If the int contains 3 and the float contains 3.0, the bits look completely different. So if you type in 3 plus 3.0, the computer goes through some hurdles in order to get those to be the same type before the addition operator is done. So the hierarchy of types. If you mix an int and a float, and it doesn't matter if, a plus b, which one is the int and which one is the float. If you mix types, the int will be converted to a float in order to do the math. If you mix a long and a float, the long will be converted to a float in order to do the math. If you do an int and a long, the int gets upgraded. It gets promoted up the scale to be a long. If you mix a float and a long double, then the float gets upgraded to the long double. So that's called promotion. And the computer will do promotion automatically whenever you have operators of mixed types. So if we have int I equal to 3, we have long L is equal to 3.0 L. And then we have float F is equal to 3.0. And then we have double D is equal to 3.0. And then we say C out I times L. Which one of those operands has to be converted by the computer before the math is done? It converts the lower type, the lower hierarchy one, to the upper hierarchy one. Which one's lower? Ints or longs? Ints are lower. So the I will be promoted to the same type as long. It'll do a conversion that takes that int, turns it into a long. There's no data loss involved because you can store a smaller data type in a larger data type easily. How about if we have this? C out which is the lower hierarchy, the D or the L? If we look at this chart over here, the highest hierarchies are here, the lowest hierarchies are down here. So this actually should be the word long. Sorry for leaving that out. So with that in mind, is the long of greater hierarchy than the double, or is the double of greater hierarchy than the long? The double's the highest hierarchy, so the long would get converted to a double. The general rule of thumb is that int types get upgraded to floating point types if one of the operators is a floating point type. And 32-bit data types like ints get upgraded to 64 data types if you're mixing 32-bit types like ints and 64-bit types like longs. Usually that happens without us even thinking about it. Usually it just all works. The only time it doesn't work is with division. If we do this, 3 divided by 4, we'd expect that to print 0.75. But it does integer math because an int divided by an int produces an int, and 0.75 is not a valid int, so it gives us 0. To get this to work, we have to make one of them a floating point type, or both. But if we did this, 3.0 divided by 4, that's totally cool. We'll get the right answer. We'll get 0.75 because the int will be upgraded. It'll be promoted to be a float so that this math can occur accurately. Type coercion, automatic conversion of an operand to another type. You can have promotion or you can have demotion. Promotion is what happens automatically when you're mixing the types of your operators. Demotion is what happens when you make a mistake and you try to assign a value into something that it can't have. So if you do this, I is equal to L. L is of a larger data type than an I. It cannot fit comfortably in an I. So that is demotion, and demotion, the compiler will flag that. It won't let it compile. The only way you can get it to work is if you put a cast in. That's the classic syntax for the cast. The textbook shows a couple others that have been invented for C++, but this is the classic for it. This takes the L and it does the long, and it does whatever wizardry is required to squeeze it down and fit into an int, but you have possibility of data loss, and I have done that right. I typed in a number that was too large to fit into an int and printed out the results. Yes or no? I'm getting blank looks.
Wait,
No.
what's that?
Okay, we will do that. So int I, int L. L holds a really big number. 999 trillion. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to tack an L on to boot just to force the issue. Okay, so I do I is equal to L because I think that's really cool and I want to add 1 to it, I++. Then I'm going to print it out. Look at that, it's not giving me a compilation error. Most strongly typed languages, of which C++ is one, would not even let this compile. Well, let's see what it does. It still didn't do what we might want. Well, I don't know what you want it to do. 990 trillion cannot be stored into an int. Oh, I see what's wrong with this. What's wrong with this code? There's a blatant error in it. I made them both ints. I should have made one of them a long, which I still think is an absurd nomenclature. Okay, but it didn't give me an error.
But it might have been a negative number.
But it is making a negative number. And the reason for that is that this is too large to fit into an int. It's too large to fit into 32 bits. 32 bits can only hold an integer that's equal to about 2 billion or less if it's a signed integer, or 4 billion or less if it's an unsigned integer. So what happens is that it throws this into the int and it chops off some stuff at the beginning and we wind up with a negative number. Why did it turn negative? Because the first bit is the sign bit. Did I talk about sign bits when we were talking about bits and bytes? Okay, so like if you have an 8-bit number, but it's a signed number, only the last 7 bits of it actually contain numeric data. The first one indicates whether it's a positive or a negative number. If it's a 0, it's treated as a positive number. If it's 1, it's treated like a negative number. So when it turned this number into an int, the first bit wound up being a 1. And so it printed it out as a negative number. So we lost some data when we demoded the data. So when using the equal sign, the type of the expression on the right will be converted to the type of the variable on the left. So before that long was placed into the int, it converted that long to an int, thereby losing that data. Overflow and underflow. Overflow is when a number gets too large to be stored in a specific data type. Like we have a byte. We're using a byte. I'm going to call it a character instead. But we have a character called level. That's our Pac-Man game. We've been playing Pac-Man for quite a while. We're on level 255. Then we go up a level. So level plus plus. Now let's print out our level. But we're going to force it to be printed out as an integer rather than a character. I hope that works. I hope it doesn't continue giving me red underlines. The reason I'm doing this is I don't want it to print like an A or a B or something like that. And the reason I chose character is because I know that character is an 8-bit type. And I know very specifically that it's an unsigned 8-bit type, so it has the range of values between 0 and 255 for reasons we've talked about when we talked about bits. So now that we're at level 255 and we try to go up one more, it's going to be different than what we might hope for. Well, I don't know what we hope for, but all of a sudden we're back at level 0. That's called overflow. We exceeded the capacity of that data type. And in the game Pac-Man, I'm pretty sure I showed y'all this. Pac-Man level 256. Yeah, the kill screen. There you go. That wasn't intentional. It's just that the programmer never imagined that there would be fools who would play Pac-Man for 255 levels and get to the 256 level. And when I say fool, I mean that's just because I admire them. You know. So, and then you would get to this level and the game would end. All you could do is eat some of the dots, you know, and you couldn't get past that level, so it's known as a kill screen. And that's because of data overflow. Underflow is when data gets too small. If we are at level 0 and then we subtract 1 from it, level minus minus, you might be able to guess what it's going to turn back into. What's it going to turn into? Well, if 255 got increased and turned to 0, then when we take 1 away from 0, what's it going to turn into? Yeah, it's going to go back to 255. That's underflow. We have gone so low that the data type cannot support it anymore. Oh, look at that. It printed -1. All right, I'm hoping that the text has a better example of underflow. So overflow occurs when you're assigning a value too large or too small to be held in a variable. The variable contains values that are wrapped around. We wrapped around from 255 to 0. Different systems, they might display a warning message, they might display an error message, they might stop the program, they might continue execution using the incorrect value, which is what Pac-Man did. It tried to draw level 0, and there was no level 0 in its ROM, so it messed up. Typecasting. Typecasting is when you specify the data type and you want to convert something to another. Here's an example of taking a character data type and turning it into an int so we find the numeric version of that value. My code was actually doing this to some extent, but I used a different syntax for the typecasting. So instead of saying level is equal to 255, I'm going to say level is equal to A. But I want to find out what an A is. Did we do hexadecimal to Ascii conversion? Okay. Anybody remember what an A is? Either in hexadecimal or decimal on the Ascii chart? It's okay if you don't, but yeah, it's 65 in decimal. So if we convert that to an int, and they use static cast, and then we print II out, it's going to print 65. Or it's going to give me an error because I got the wrong syntax. Static cast use angle braces, not parents.
What is static cast? That's just converting.
It takes whatever's in here and converts it to that data type.
Okay.
And so II equaled 65 because it was A, but it got cast to the type of int. And the ASCII value of an A is 65. So inside that character, that's really a byte that contains the value 65. And so we cast it to an int to extract that so it would no longer be treated as a character, instead of be treated as a number. Now there's more than one syntax for casting. That's a complicated looking syntax if you're used to, as I am, this syntax. This syntax is much more common in a lot of different languages, including Java, and it originally came from C, back in the 70s. So right offhand, I don't remember why this more complex syntax was introduced in C++. If you know, tell me. I guess we could Google it. Same idea. If we print this out, it'll say that II is equal to 65 because the ASCII value of that character is 65. You can use any kind of casts. if we do I is equal to static underscore cast, and we turn it into an int, and we pass in a long number, 300L, it'll do whatever's necessary to take that 300 and store and turn it into an int. Was that strictly necessary? It would have done that automatically, but there we go. I is equal to 300. If this number was too large, if it was 300 trillion or whatever, it'd probably wind up being a negative number. So C-style casting is when you put the data type inside parentheses. The pre-standard C++ cast changed the syntax to this. And then when C++ was standardized, static cast was introduced. If I give you any examples, I'm going to use this syntax because you will see that in a lot of other languages, and you will only see static cast in C++. Just be aware, if you see static cast, what it's doing. It's taking whatever's passed into the parentheses and turning it into whatever type was specified in the angle braces. If you see this, it's doing the same thing. It's taking that and turning it into an int. Multiple assignment and combined assignment. This will be about the last thing we hit, won't it? Actually, what I want to do, all I want to do is have some fun. Okay, here we go. We have a sphere coming up on 19, and we have a BMR coming up on 19, so I feel okay about not giving you more homework. All right, why don't we call it a day? Are there any questions or anybody need any help with their homework? We can hang out and do that. Otherwise, I will see y'all on Tuesday. And by the way, if you answer, no, I don't agree to these rules, I'm going to go ahead and grade your exam, but you're not going to get credit for that first question, which was worth 5 points out of the quiz. So you might take it again, just so you get a perfect grade.
Next week.
Mm-hmm.
Tuesday I'm not gonna be here. Thursday I probably won't be here. My wife's giving birth Monday, so
Well, cool.
yeah.
You may not be ready for the exam.
Well,
If you feel
as
like you're
long
ready
as-
for it,
Yeah, as long as there's still, cause I'll go in D2L and I'll look at
okay,
that.
if you're watching the videos, then you should be ready for it. But if for some reason you feel like you're not, I don't mind you taking it late because that's a serious life event. I
Yeah,
understand
yeah,
that.
yeah.
Yeah.
Okay.